This is the last problem in Ztransforms. So it goes like this. A causal LTI system is described by the difference equation y of n is equal to y of n minus 1 plus y of n minus 2 plus x of n minus 1. So first we need to find system function. What is system function? System function is h of z. Next, we need to plot the poles and zeros. We need to plot the poles and zeros. Then indicate the region of convergence, that is ROC, we need to indicate. Then we need to find out the unit sample response of this system, that is h of n. Then find a stable but non-causal unit sample response that satisfies this difference equation. So finally, we need to find out h of n for a stable system. Okay, these are the 5 points we need to find out. So clearly, I can explain it from here itself. So y of n minus 1, y of n minus 2 are the terms related to output. So we can take it on left hand side and input is on the right hand side. Okay, so applying the Z transforms, what do we get? For y of n, y of z, y of n minus 1, z inverse into y of z, y of n minus 2, z inverse square into y of z. So taking out y of z as common. So let me write it here. Y of z minus z inverse y of z minus z inverse square y of z equal to, this is z inverse into x of z because of the x of n minus 1 term. Okay, so taking y of z as common, we will get 1 minus z inverse square. So taking this to this right hand side and x of z onto the left hand side, what we get? Z inverse divided by 1 minus z inverse square. So taking z inverse square as common, if we take common, we get this equation. Okay, now applying the quadratic equation ax square plus bx plus c, we get the roots as z plus 0.618, z minus 1.618. So similar kind of problem we have previously solved. So this is a first point, system function. This is our system function. Okay, now pole zero plot is what? How to find out pole zeros? If you substitute this as 0, then it is a zero plot. So there is a 0 at z is equal to 0. Okay, z equal to 0, there is a 0. If we substitute z is equal to 0, h of z is equal to 0, correct? So that is 0. Now if you substitute z plus 1.618 equal to 0, this will become z is equal to minus 0.618 minus 0.618. This is one pole. Okay, second, z minus 1.618 is equal to 0. If you substitute, z will be equal to 1.618. This is another pole. So using these two poles and 0, it is been plotted here. You can see there is a 0 here and there is one pole on the negative axis minus 0.618 and 1.618 is here, and this is unit circle. Okay, so this is the pole zero plot. Next is we need to find out the given system is causal, assuming that ROC we need to find. For that, what is ROC? ROC must be for a causal system outside the outermost pole. So it should be outside this 1.618. So ROC is Z greater than 1.618. Now, fourth point is, this is about the ROC. Fourth point is about calculating H of n. For calculating H of n, we need to apply partial fractions. So after applying the partial fractions, that is, for the given problem, what we had is Z divided by 1 plus 0.618 into Z, sorry, Z plus, here it is Z inverse. So both the ways you can do it. Plus Z divided by Z minus 1.618. Okay, this was the H of Z. Done for that. So this was our H of Z. For this, if we apply the partial fractions, we will get this answer. That is 0.447 minus 0.447 divided by 1 plus 0.618 Z inverse, or you can say this as Z and Z plus. Both are same. This will not be there then. Okay. So you can follow one method. Either you convert everything into Z or you directly use Z inverse itself. So this is minus 0.447, whereas this one is 0.447. This is A1 and this is A2. Okay, using this we rewrite H of Z. Now taking the inverse Z transform for the causal system. For causal system, we get always U of n terms, correct? So you can clearly see it is minus 0.447 this term into minus of this, because it is plus here. Here we'll get a minus of 0.618 to the power n U of n plus 0.447 this term, then this is 1.618 n U of n, because our ROC is Z greater than 1.68. So obviously it is greater than 0.618 also. So ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಅಂದ್ರೆ ಈ ಟರ್ಮ್ ಇನ್ಕ್ಲೂಡ್ ಆಗಿಬಿಡುತ್ತೆ, ಅದಕ್ಕೆ ಎರಡು ರೈಟ್ ಸೈಡೆಡ್ ಸೀಕ್ವೆನ್ಸ್ ಅಂತ ಹೇಳಿ ಅಸ್ಯೂಮ್ ಮಾಡಿಕೊಂಡು ಈ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ದಾರೆ. ನೆಕ್ಸ್ಟ್ ಫಿಫ್ತ್ ಪಾಯಿಂಟ್, ಸ್ಟೇಬಲ್. ಫಾರ್ ಸ್ಟೆಬಿಲಿಟಿ, what is the condition? ROC must include the unit circle. Correct? Unit circle, that is what given here. So it can be, magnitude of Z can be greater than 0.618, magnitude of 0.618, but it is lesser than 1.618. Okay, that means this would be a right sided sequence, whereas this would be a left sided sequence. Okay, ಅದಕ್ಕೆ ಇಲ್ಲಿ ಏನು ಬಂದಿದೆ, this is same as previous one. ಇಲ್ಲಿ ಏನಿತ್ತು, ಇದೇ ಟರ್ಮ್ ಬಂದಿದೆ, ಆದರೆ ಇಲ್ಲಿ ಮೈನಸ್ ಆಫ್ ಮೈನಸ್. ಸೊ ಇಲ್ಲಿ ಪ್ಲಸ್ ಇತ್ತು, here we get minus 0.447, then 1.618 to the power n U of minus n minus 1. So left sided sequence. Okay, so this is right sided because Z is greater than 0.618 and lesser than 1.618. Okay, this you need to remember. For a stable system, what we are assuming is ROC must include this unit circle. So we have a point at 0.618. So let me draw a circle like this. Okay, and another pole is at 1.618. So I will draw another circle like this. And ROC is what? ROC must include the unit circle. Let me draw it again, unit circle. So if I draw a unit circle like this, it should include this unit circle. So ROC must be greater than this circle and lesser than the second one. So if you look at here, sorry, at this point, the ROC is outside 0.618, whereas it is inside 1.618. So this is the pole corresponds to this will be right-sided sequence, and for this one it will be left-sided sequence. Okay, so that's why we have written in this way. I hope this is clear. That completes our Z transforms. Thank you for watching.